So the next most important thing we need to do with vectors is learning how to add vectors together. Now, fortunately, there's a really nice, easy trick to do this, and it's called the head-to-tail method. So I'm going to just quickly show you. I'm going to put this little red vector there, and we're going to add it to this little green friend here. So these are our two vectors. We're not going to change their direction or their sense. They're just going to stay like this. But what we, because these are, I've cut these ones out, these ones I can move around just to demonstrate how this rule works. Now the head to tail rule works by joining the head of one of the arrows to the tail of another. So very simply, without changing the direction, I'm just going to put them head to tail. So that's the first step. The second step is to create a resultant, or so essentially the sum of them. Once we've added them, we get a sum of the two vectors, which we call the resultant vector. And the way we do that, so we've gone head to tail, and then we draw a resultant that goes tail to head. So I'm going to get my ruler out and draw a vector that goes from the tail, tail to the head. So I've got my little arrow on there. Beautiful. So that's now my resultant. Now, the beauty of the head to tail rule is you can do it in any order you want, and I'll quickly demonstrate that now. What I'll do is I'll just we'll move this one out and put this guy here. We should find that we get the same resultant vector, and even though we reverse the direction that we added them together. So it doesn't matter which way you add them, as long as you do them head to tail and then tail to head for that resultant. So I want to demonstrate this one more time. This time I'm going to throw in a third vector, just to show you can do this with a unlimited set of vectors. So here we've got the little bluey, green, and red. The exact same method applies. We just go head, like I said, it doesn't matter which order I'm doing, head to tail, head to tail, and my resultant is going from the tail to the head. There, that's now my resultant. Like I said, it won't matter if I change the order around. Let's see, let's put do my best here not to change the direction. Actually, this is a good example. What I'll do is I'll just, there we go, beautiful. Now, oh, it's not easy with these little cutout guys, but there we go. You can see that I still got the same resultant regardless of how I added them, the order that I added them together. So that's how you do it with a nice cutout one. Let's have a little quick look at the example that you're given in your book. And I just want to show you a few little tips to make this nice and easy for you. So first thing, we're going to be adding a whole bunch of vectors here. What I recommend we do, just for simplicity here, is starting at the bottom of the D, because it's a really shallow angle. And to be honest, it actually won't matter what angle I choose here as my reference point for my x-axis. I could open up that D as long as they're all on the same axis, but I'll just, for simplicity, I'm just going to keep it nice and straight. So what I'm going to do is I'm going to draw an axis on D, C, B, and on A. So these are now the angles at which I'm going to measure. As I said, I always measure from the horizontal. Now, the reason why I need to do this is I need to redraw these vectors. So I'll get my protractor out and I'll quickly measure these. Okay, now that I've got my two angles measured up, I'm just doing this part here, question 1, so I've just measured A and C, but I would initially do B and D as well, but you can do that. So now what I need to do is create a new axis point here. So, it might be, yeah, I'll just start down here. So this is going to be for my first axis, which is the letter A. So the other thing I need to do is measure their lengths. So I'm going to say that's 36 millimeters, and C is 30, where is that? 1, 2, 3, 38. 38 millimeters. So at this point now, I'm going to draw 36 centimeters on an angle of 36. So I'm drawing vector A, starting at this point here. I want it at 36 degrees. I need 38 millimeters. No, 36, my apologies. 36 millimeters. And now, it is important to put your arrowheads on so that you know which way you're doing. So we're going in this direction, so there's my sense. And now, I'm going to draw number C from that angle there. Now, there's no great way to do this, but you're basically drawing a new axis on here. Now, the reason why I'm being really precise about these measurements is because we're drawing this to scale. Minor little, if I make mistakes about that little axis by 1 degree, it's going to really affect my final resultant vector. So you do really need to be careful when you're doing this. Right, so I'm going to measure up 66 from here. 66 is right there. Okay, now I need to go 38 down. Alright, head to tail rule. Now, to finish off, to finally get my resultant here, I'm now going to draw from the tail to the head. Now, in doing so, I can also get my final magnitude, which is going to be approximately 18. Now remember that in this question there is a scale issue, so to get the final magnitude, you'd assume that these are using standard units of meters, so this magnitude will be, 18 times 100, so it'll be final displacement of 1800 meters, and the angle, you can do it as a bearing if you wanted to, or you could do it as from the horizontal, which is, as I've always said, is my preference. So I'll be measuring that angle with my protractor and putting that, measuring this angle and getting my display, putting in that angle there. So that's the head to tail rule. It's very, very useful. It is a little bit tedious when you're doing these scale diagrams, but all the same, a very valid and effective way to measure or to add the sum of vectors.